Hi guys, so welcome back sa ating YouTube channel. So ito na yung lesson 4 para sa ating chapter 2 sa Calculus 3. So in this video, pag-uusapan naman natin yung directional derivative and the gradient. Okay, so this is a pre-introduction to gradient, although i-discuss ko pa siya sa last chapter ng ating Calculus 3. Okay, so let f of x comma y be a real valued function with domain D in R squared, and let a comma b be a point in D, and let b be the unit vector in R squared. Okay, so yun, may unit vector na tayo again. Then the directional derivative of f at a comma b in the direction of b, so again directional derivative siya, papunta sa direction ng vector b natin o yung unit vector natin, denoted by d sub b of f of a comma b, d sub b of f of a comma b. Okay, so comma b tuloy. So is defined to be as directional derivative of f at a comma b is equal to the limit as h approaches 0 ng f of a comma b plus hb. Okay, so para siyang dating is parametric equation. Okay, so a comma b plus hb kasi alam natin yung b is a vector. Okay, vector in R2. So given na kung R2 siya, R2 yung given. So minus f of a comma b all over h. So kung gusto mo kunin yung directional derivative, yan lang yung gagawin natin. Okay, so meaning, isa-substitute natin yung parametric equation sa loob ng function. Minus f of a, comma, b. Okay, so although ang sagot naman dito is something na parameter lang din actually. So parametric din naman yung sagot dito in nature. So parang sagot dyan is, for example, unit vector natin si b sub 1, b sub 2. So parang ito lang ay just equal lang sa f of a plus hb sub 1, comma, b plus hb sub 2. Okay, so parang ganyan lang yung kanyang term. So minus f of a comma b all over h. So yun yung gagawin mo. So technically, syempre, alam mo na sir, ang hirap naman ang. So again, meron tayo derive na ibang formula. So bakit binibigay ni sir yung hindi naman ginagamit? Kasi yan talaga yung mathematical definition nila. Tulad kanina sa limit. May mathematical definition sa limit, pero may way tayo paano siya i-solve. Sinasubstitute lang natin. So approaches siya, so may mathematical definition siya. At the same time, si partial derivative. So napansin mo, si partial derivative is may definition through limit. So yun talaga yung mathematical definition niya. But there is a case na kung saan tinuro ko lang na consider mo to as constant, as differentiate mo lang to, ayun na yung sagot. Okay, so tandaan yung bagay na yan. Okay, so again, this is just a mathematical definition. So sa kahit anong book, yan yung kanyang definition. So although may formula siyang iba. So now, let f of x comma y be a real valued function. This is theorem 2.4.1. So with domain D in R squared, such that the partial derivative of f with respect to x and the partial derivative of f with respect to y axis are continuous in D. Let a comma b a point in D, and let b be the unit vector b sub 1 comma b sub 2. So tama ko na nilagay. Be a unit vector in R squared. Then this is just equal sa, kung gusto natin i-revise yun using this theorem, so kung ayaw mo gamitin yung limit, pwede natin i-apply to using the partial derivative. So ano sagot? This is just the directional derivative of f at a comma b is just equal sa b sub 1 times the partial derivative of f with respect sa x of a comma b plus the partial b sub 2 times the partial derivative of f with respect sa y of a comma b. So katulad ng sinasabi ko, paano ulit gagawin dito? Ang gagawin natin dito is just, kung meron kang given na a comma b, so kunin mo yung partial derivative muna ng f natin with respect sa x, substitute mo yung a comma b. Similar dito. Kunin mo yung partial derivative ng f with respect sa y, then substitute mo yung a comma b. Then multiply mo lang dun sa second coordinate ng unit vector, then yung first coordinate ng unit vector respectively. So ibig sabihin, ang sagot sa directional derivative is something na scalar in nature. So kasi sagot siya actually. So since number yan. So sagot siya actually. So directional derivative siya. So yun yung gagawin natin. So again, yan yung ating formula na pwedeng gamitin. Okay, so next is for a real valued function f of x comma y, the gradient of f denoted by del of f. So actually not del of f. So that symbol, so gradient of f is the vector. Gradient of f is equal to partial of f with respect sa x, comma partial of f with respect sa y. Okay, so ayun lang. So walang a comma b. So at least kung may partial derivative niya with respect sa x and partial derivative with respect sa y. So yun yung ating gradient. Okay? So now, in R squared, this is just, so yan yung in R squared for real valued function. So in R squared, ito yung para sa R squared. Now, for a real valued function f of x comma y comma z, the gradient is the vector partial of f with respect sa x, partial of f with respect sa y, comma partial of f with respect sa z. So yun yung ating gradient niya. So, yung gradient natin is the vector na ito in which in r cube na siya. Then, the symbol is pronounced as del. So, tama, del nga siya. So, actually, parehas din pala nung isa kanina, no? So, del. So, yan yata yung other term. Hindi ko alam kung bakit sila parehas ng partial derivative eh. Pero del din kasi talaga basa kanya. So, huwag mo isipin na del isang banlaw yan. Okay, so, wala yan dun. Okay, so now, ito yung ating illustration. So, consider natin, ito yung graph natin na to. So, kung ito yung vector natin, so ito yung function natin, constant function siya. So, yung vector natin direction doon, ito yung gradient. Okay, yung vector is direction doon, ito yung gradient. So, kung napapansin mo, yung gradient natin is always perpendicular sa ating unit vector. Again, perpendicular siya sa unit vector. So, yan yung figure 2.1. Then, we have this corollary. Ito pa yung mas maikling way para ma-solve. So, actually, na-derive lang to from our equation. So, the directional derivative of f at a, b is just equal sa the vector b dot product the gradient of f. So, which is tama naman. So, kung napansin mo, dun lang din galing yan. So, pag iiwalay natin yan, this is just b sub 1. So, this is just b sub 1, comma b sub 2, multiplied by partial of f with respect sa x, comma partial of f with respect sa y. So, this is just equal sa unit vector multiplied by the del of b or the gradient of f. Del of f pala rather. Okay. So, kung tatlo siya, alam mo na gagawin. So, yung unit vector natin is b sub 1, b sub 2, b sub 3. Okay. So, kung nasa 3-dimensional space tayo or sa Euclidean space. So, i-adjust mo na lang din yung mindset natin sa ganong bagay. Okay. So, now, proceed na tayo dito sa ating mga example. So, again, medyo mabilis lang din talaga itong video na to. So, dapat pala sinama ko na lang siya sa tangent plane. Pero, ayun nga. Hinibalay ko na for a sense na dapat siyempre maiba yung idea. Baka kasi maghalo-halo since pare-parehas na siya ng formula. Pare-parehas na ng actually yung ginagamit na term or something na symbol. So, talagang nakakalito siya. So, kaya talaga hinihiwalay ko para at least whenever nakalimutan mo, ano bang topic yun, nalagay ko siya dito. Again, so wala ka ibang purpose. Yun lang talaga yung purpose ko dyan. Okay, so we have the example. So again, ito yung pwede natin gamitin. Corollary. So, galing lang din yun. So now, find the directional derivative of f of x, y is equal to xy squared plus x cubed y at the point 1, 2 in the direction of b, directional vector b, 1 over square root 2, 1 over square root of 2. So again, directional derivative. So, I think pwede natin siya hanapin in two way. So, in two way natin. So, pwede natin hanapin una is yung gradient. Okay, ito saka natin apply yun. Okay, or gamitin natin itong formula na nauna. So, try natin gamitin itong unang na formula. So, una is gradient muna. So, hanapin natin yung gradient of f. So, for the gradient of f, this is just equal sa partial derivative with respect sa x nung lagay ko yung function, this is x y squared plus x cubed y. Okay, comma, partial derivative with respect sa y nung similar function, x y squared plus x cubed y. Okay, so tama ba ako na nilagay? So, ayun nga. So, nalagay ko na siya. Okay, so next is simply, this is just equal sa the partial derivative nung x squared, xy squared is just y squared. Partial derivative ng x cubed y with respect sa x is just plus 3x squared y. Tama? Then, comma, this is just partial derivative of x, comma, ng partial derivative ng x squared y squared with respect sa y is just 2xy. Then, plus, with respect sa y, this is just x cubed. Okay, so note that if we use the del, so the del of f at a specific point natin na 1, 2, so sa substitute natin yan. So sa kami, yun yung idea nun, substitute mo lang siya after nun. So the del of f is just equal sa 2 squared plus 3 times 1 squared times 2, comma, so lakayan ko lang to, comma, this is just 2 times 1 times 2 plus 1 cube. Okay, so tama ba ako na pag-substitute? Baka naduling na naman ako sa 2 squared plus 3, 1 squared, 2. Okay, then plus 2 times 1 times 2 times plus 1 squared. 1 cube rather. So this is just the del of f So the del of f is just equal sa 2 is 4, 2 squared is 4 plus 3, 2, 4 plus 3, 3 times 2 is 6, no, plus 4, this is 10, comma, this is just 2 times 2 plus 1, so this is just 5. Okay, so the gradient vector at 1, 2 is 10, 5. So therefore, the directional vector, the directional of f is just equal sa unit vector b dot product sa ating del f. So this is just equal sa, this is just 1 over square root of 2, 1 over square root of 2 dot product ng 10, 5. Okay, so in such a case, this is just equal sa 1 square root of 2 times 10 plus 1 square root of 2, 1 over square root of 2 times 5. So this is just equal sa 10 over square root of 2 plus 5 over square root of 2, or simply this is just 15 over square root of 2. So therefore, the directional derivative is just 15 over square root of 2. Okay, so yun ba yung sagot? Tama ako. So yan yung ating directional derivative. Okay, so napaka-dali na. Okay, so next is kunin natin ang pangalawa, no? So find the gradient of f of x, y is equal to x squared plus y squared minus 1. So since wala naman binigay na a, b, yung gradient lang is just ganito. Again, may dalawang klase tayo ng sagot sa gradient. So pag merong point na binigay, so yung gradient at a specific point, substitute mo lang. Okay, pero ito yung nasa taas, gradient na yan. Okay, again, gradient na yan. So, tandaan na, gradient na yan, pero dahil may specific point at gagamitin sa directional derivative, ito yung ginamit natin. Nag-substitute pa tayo ng 1, 2. Okay, so tulad na ito, find the gradient of f of x, y is equal to x squared plus y squared minus 1. So, simple, ganun lang din yung gagawin natin. So, kunin natin yung gradient. So, for the del of f, so for the gradient of f, this is just equal sa partial derivative with respect sa x. So, copy natin si x squared plus y squared minus 1. So, ang dali yata na ito. Comma, partial derivative with respect sa y ng x squared plus y squared minus 1. Then, this is just. So, therefore, this is just equal sa partial derivative niyan with respect sa x is just 2x. Then, this is just 2y. Okay, so therefore, the gradient of f is just this. Okay, so ang dali naman niya. Ano ba yan? So, hanap pa nga tayo example. Hanap lang ako example. Masyado madali. Ayun, may nakita na ako isa ulit. Dagdagan ko kasi medyo madali eh. So, ayoko lang talaga kayong nahihirapan actually. Hindi naman talaga totally ay mahirapan. Pero something na, so kunyari for 2 point B. So for example, meron tayo f of x, y, z ng x squared e raised to yz. Okay, so for letter B, hanapin natin del. So yung gradient of f dyan, syempre, medyo malaki. Kasi tatlong variable tayo. So gradient of f is just equal sa partial derivative with respect sa x nung una, x squared e raised to yz. Okay, comma, partial derivative with respect sa y nung x squared e raised to yz. Okay, comma, partial derivative with respect sa z. So, since tatlo na siya, nung ating x squared e raised to yz. Okay, so actually parang madali pa rin naman, no? So, para sa una, this is just equal lang sa, siyempre dahil hindi naman siya magpa-product rule, malabo siya sa product rule, no? So, since x squared lang yung ma-differentiate, that is 2x, just copy si e raised to yz. So, para sa una, this is just 2x, copy si e raised to yz. Again, so matahan na lang. Next is, si x squared is magiging constant kasi with respect sa y tayo. So, meaning, bababa si z. Kasi e raised to yz, so, partial derivative ng e raised to yz with respect sa y is just z e raised to yz. So, this is just x squared multiplied by z e raised to yz. Okay, comma. So this is just x squared ulit. So dito naman baliktad, magiging y e raised to yz. Kasi magiging consider naman natin si y dyan as constant. Okay, so now simplify natin further. So the del of f or the gradient of f is just equal sa 2x e raised to yz comma x squared z e raised to yz comma x squared y e raised to yz. Okay, so therefore ito yung kanyang gradient. Okay, so that's all in this video. So hoping na nagets mo yung ating directional derivative and gradient. Okay, so hoping na panoorin pa yung last topic, which is maxima and minima. So what if naman apply natin na maximum and minimum yung ating, so actually may critical point, so may mga, actually wala naman inflection point dito kasi iba na siya sa 3D dimensional. So again, hoping na manood ka pa sa next video.